I titled this talk was sort of originally more about Tower, and I will definitely get to that. But before I go into the Tower piece, we've been spending a bit of time internally in the organization at Seqera Labs, just kind of thinking a little bit about what kind of organization we are, where the kind of focus is. We've come obviously from Nextflow as kind of the founding sort of part of the company. But since the addition of Tower and obviously some other things that we've been working on, I guess the missions are kind of expanding. And then so we're kind of going through this process at the moment of thinking about what kind of organization we want to be. Obviously, there are some key things around Nextflow that we want to, I guess, some values of Nextflow that we obviously really like and that we would like to keep as part of the company as well. If you just think about the first sort of experience you have, or at least myself, very early on, running a Nextflow pipeline and just the power that it gave you when it started submitting tens of thousands of jobs to the cluster. That kind of feeling of simplicity, of really making a complex problem much easier and more tractable was really kind of powerful for us as well. Beyond the kind of technical things, though, there's a whole piece of it which is the value of community, and we definitely see that here today and over the last couple of days as well. And this is something which continues to grow. We see a lot of this around the ecosystem. I think we just saw 3 new front ends for Nextflow in the last 4 talks. So this idea of is really kind of expanding on, and it's fantastic to see. We also have this idea, and it's really about the power of integration. Whenever you use Nextflow, the idea is that you're kind of jumping onto existing tools that you're using, making those easier, and making them all kind of play together in a nicer way. I mean, that's something, of course, we want to keep. And the real big thing I've been thinking about more recently, and this is a little inspired by a trip that I took to California a couple of weeks ago. I didn't go to the desert. It was to the CZI Open Science conference there. And from that, it kind of made me think a lot about what we've been doing with Nextflow over the last few years and the impact that has had on open science. I think is maybe being a little underappreciated by ourselves. So I wanted just to start a little bit on that piece and go through that. So here's one definition of open science here, which is around improving the quality, accessibility, and the efficiency of science. But there's other kind of elements to it, and this is from an academic paper that's sort of looked at the 5 schools of open science. Ones which we can all associate with very easily is the idea of infrastructure. This is like kind of like infrastructure and tooling, things that we all do. But then there's also the idea of collaboration, of having open code, open source as well is a big piece of that. There's also the idea of citizen science and how that feeds into these things. And an aspect of it relating to Cedric's talk, which is around measurement. How do we have attribution? How do we do publications for all of this that we're working on itself? Okay, so just kind of summarizing sort of what I've been learning about open science and how it relates. If you think about the infrastructure and tooling, that's pretty obvious from what we've seen over the last couple of days. The enabling of the collaboration, I think, is a key piece, something that we continuing to build. Moving from just being one person at the terminal to being able to share your work with whoever needs it and making it more accessible, of course. There's a whole piece around incentives and attribution. Which is still obviously a lot of work to do. And I guess I would say that we're all at the forefront of this, and in some way we are all early adopters of many of these values and these principles. But generally in science, I think there's still a lot to go, and there's sort of a lot of work to be done. So all the work that we are doing, I really believe is taking us in the right direction with regards to this. And open science is not just about academia. In fact, I would almost argue that open science is even more important when it comes to industry, or at least the fruits of open science are all enjoyed in industry, particularly in genomics, particularly the space that we work in. We can all think of examples of the data resources, things like the Human Genome Project were made sort of public on day one, all of the resources we use for read archives, etc. The applications themselves, which are fundamental to all the pipelines we're developing. All of those things are written in Conda, with things like GATK, other things like multi-QC as well. All of those things are kind of pivotal to this. The pipeline collections, we saw before with Epitome. We've also got some folks in the audience from BC Bio and NF Core. And then, of course, the workflow managers, things like Nextflow, SnakeMate, Cromwell, etc. All of these are very widely used in industry and increasing, and then kind of use is increasing as well there. If we think about platforms for open science here, things like Tower, Galaxy, Avados, the publications of actually making those things available for everybody, as well as things like protocols and even hardware. Now you start to see this open science movement, which is really kind of taking shape as it moves forward. Okay, so now kind of thinking about this open science, we're trying to think like how do we do that, and like what is our piece in this story? And I think the way we've been trying to think about it is, while Nextflow is fantastic at acting in this for the workflow execution piece, the high throughput compute, there's a whole lot of adjacent problems around it. And I guess now with the sort of expanding team, but also with the amount of interactions that we get to have with users and customers, it's providing us with a lot of feedback on how we can approach things and almost like do things in a Nextflow-like way across other aspects of what we do. So a little in summary, so science is definitely becoming more open. And I think that we all can kind of see that with the work that's going on. I would also argue that the organizations that do embrace open science will do better. So there is a whole kind of a spectrum of adoption here. And I see it with a fantastic example like from Oxford Nanopore, where they are making all of those pipelines, which are for their system, but they're making them all open source. They're making them all available for people. And I think that's the kind of things which will end up actually benefiting them as well. It's not a zero-sum game here. And we particularly think about the kind of challenges that we're facing with regards to the diseases that we're trying to eliminate. All of that becomes sort of helpful in driving some of those things away. So what's our piece here? We're starting to think about this as not just the execution of the workflow, but more on the whole data analysis life cycle. And for us, that sort of starts with the development. You can think of developing tools, developing of the workflows. There's obviously many aspects to that. We also think around delivery. So we saw today, earlier with Wave, but there's the idea of containers, the kind of DevOps aspect of the kind of science that we do, and the infrastructure. There's the data management piece. We haven't had so many talks on that yet, but obviously there was the piece from Quilt, but this is kind of another key thing that we think has to be built out as well. The high throughput aspect, I guess, is the piece that we feel at Seqera is probably most sort of evolved from. And then we have the interactive bits, the idea of using notebooks, RStudio, IGV, and finally on the reporting. So if this is the challenge, I guess, that we're trying to resolve, how could we go about that? Well, you might think that like starting from the scratch it's a lot of work, and there's a lot of things, and there's many different ways to do it. But in reality, we have actually quite a bit of a head start in many of these aspects. So if we consider some of the things that we either support or our Seqera projects already, there's things like the NF Core tooling, there's the VS Code plugins for development. We have things like Wave, containers, Fusion, Tower Forge, which goes and creates that infrastructure for you in the cloud. There's the whole data management piece, things like SRA Explorer and Tower datasets. Still very early in where we want to take these projects. But there is definitely the beginnings of it there. Obviously, Nextflow for high throughput, and very happy to announce today as well that MultiQC will be coming a Seqera project as well. So we'll be able to support and fund those really foundational tools for open science. And really, that's the kind of key of this is to try and build these projects out in that way, in the same way, the same values that Nextflow has as well. Okay, how does it all fit together? Well, you can imagine you've got all of these different pieces here, which sort of have to come together. There's also some element here, and this is sort of the entry into Tower. There's some things you don't want to do more than once. For example, you don't want to have to create a different database for every single time you do one piece of this pipeline or one piece of this analysis. Same with back-end services, front-end services. The stuff that we do for access control, like role-based access control, APIs and CLIs, it's all gritty work and it has to be done, but ideally we don't want to replicate that many ways. So one way to do that would be to create like a pure cloud platform that you just run fully in the cloud, in your environment. You can control all those pieces. We've taken a slightly different approach, which is a more challenging one, is that we kind of do the infrastructure layer at the bottom here, but then we allow people to run that in any cloud, in any cluster. And I think this is still the key point of why Tower is so different from any other sort of genomics in the cloud system, is that you can take it, the whole thing, you can install it, you can run it wherever you want, it's essentially fully sort of transparently deployed as well, and that kind of helps a lot with these aspects. So I'm going to go now into some of the more kind of features of Tower that we've got coming up. So, and some of these things are have been out for a little while, and just sort of comments as well, and where we're going with the direction there. There is the concept of Tower data sets, and this is typically used for structured data. We are now using the input schema, which was developed with NF Core, so it's another kind of great example of taking something from the community, using that as an inspiration for that, and essentially can be built once and everyone can use it there. The other key thing I think that we haven't really stressed previously around Nextflow and data sets is Nextflow's integration with all of the storage environments. So Nextflow can integrate with so many different file types, with so many different protocols there, that allows us to really build very powerful integrations and allowing to access data in many places. We have some big plans for this, but it's probably more likely for next year around that. We also have a launchpad. This is really designed to make it easy for people to launch those pipelines, maybe people who, in the wet lab, for example, or people who are, say, running the same pipeline often. So this is a feature which has been quite widely adopted as well. And of course, reports. Reports is something that came probably about 4 or 5 months ago. Reports themselves provide a fantastic way to capture the outputs of your pipelines and really have them in one place. And the really nice thing about this, and why it's slightly different, is that if you notice here, it's actually pointing to the original file location. So Tower is almost acting like a glass view into the actual location of that file. In this case, it's an S3, but it could be anywhere there. It makes it easy to go back and find that information as well because it's associated with your run, which you can search for or find as well. Part of this is done from a config file, so we have in this case, it's a file which defines exactly what the outputs are. And Nextflow actually looks then for these files. So Nextflow will look for a file called multiqc as part of that step, and then Tower will be able to read that as well. That's just kind of another quick look on the reports there. Now you can have structured data, so things like TSV files, you can have PDFs, HTML, images, etc. And we're expanding this out, and this is kind of probably the starting direction that we'll take for the interactivity that we've got planned as well. Organizations and workspaces is a key feature. This is something that allows you to essentially have different organizations inside of it, so it's a multi-tenant system. But you can define the security boundary then of each of those workspaces, so you can say who can do what, so fine-grained control of that as well. And of course, all of Tower is run from API and CLI. Particularly with regards to the CLI, we see a lot of people who are now basically defining the whole research environment. So you define all of your workflows, all of your kind of projects, etc., and that can just be pulled from a Git repository then and fully defined there. We're also seeing lots of organizations who are building on top of Tower, who are basically using the API and building their own front end, and that's fantastic to see that kind of the sort of evolution of that, and a lot of it's coming from scale. So many people are running 50,000 samples a month through Tower, let's say, and for them, they really think API is kind of key to managing that as well. Some other things we've had come out recently is Illumina Dragon. So this now runs on AWS. What the setup does here is really try to simplify many of the things, but it allows you to use these FPGA instances. It creates an F1 queue for you, in this case an AWS batch, and then uses the Tower secrets for the license manager. And here you can get obviously much accelerated secondary analysis. And a lot of these things, it's a kind of almost like a way that we can show very easily how to make something which is pretty difficult to set up, usually very simple from the context of Tower as well. Other features around search and label. So we've been doing a lot of work on the application with regards to organization. Just how do you structure different entities in the organization, for example, pipelines and runs. So we have this ability now to create labels. And from those labels, then you can search for them very easily. And it makes it a sort of much more organized way when you have a large number of runs inside of that space. And of course, what we heard earlier today from Paolo, we also are launching today Wave Containers in Tower. This is a single switch that you switch here inside of Tower itself in some of these workspaces. And what this will allow you to do is the container authentication, obviously the performance improvements there as well that we mentioned before. The other piece that I can sort of explain would be around Fusion, and that's also a one-click option and as part of that. What we kind of see here is, and the reason why those two things are so essential is that With Fusion, we're essentially injecting into the container that particular layer which is required for that. So previously, there's some stuff that work was done with Fusion at the VM level. The fact that we can now modify those containers or augment those containers means that we can apply these kind of lower level file systems, for example, inside the container and move forward with that as well. Also very excited to announce today that we're launching Google Cloud Batch in Tower. This had been out in Nextflow for a couple of months in beta, but this is really a kind of much more simplified setup, and it really has some performance improvements over the life sciences executor as well. And then a couple of other things that we've got really around the management of Tower. When you start to run with either multiple organizations or multiple workspaces, it can get a little bit difficult to kind of see exactly everything that's taking place in the kind of application layer, particularly for admins, etc. So we're launching today the dashboard, which provides you an overview of different workspaces and different organizations, so you can track over different periods of time the exact status of those jobs. As well as related to this is an admin panel, which allows you to manage the applications or manage the users within inside the application, primarily for people who are monitoring or essentially if they are administrating their own instance of Tower, they can do that as well. Okay. Next, I'm going to talk about cost and cost control. This is a tweet from Anshul, and it was kind of popular. I'm not sure if you can read it super well, but it was basically a story, a kind of story of how they moved to the cloud for their to basically do their analysis. In this case, it was some analysis with encode data. The lab grew. It was very difficult for them to track the costs of this, and really the accounting there made it very difficult. I think it was a sad story in the end. I think they had to close down the lab, but hopefully it doesn't get that dramatic. This is a key problem of costs control and in trying to account for this, and it's something that we've been trying to work on for a while and try and do it in a way which essentially will work everywhere. So today we're announcing resource labels. And what resource labels allow you to do, they allow you to tag resources like computer environment, in this case here, and those labels propagate through to the cloud provider. So in this case, you can see that I've placed 4 labels inside of this computer environment. When I run, Nextflow is basically going to take those tags and put them on the virtual machines that get launched as part of that, and then I can go through and use my Cost Explorer. So here's an example of that, those same tags that get placed through into AWS Batch in this case, and then onto the actual VMs, and then I can search for those tags in my Cost Explorer, and I can say, how much did I spend on that date, on that month, and it provides us much simpler organization of that. The other really cool thing about that is that we're launching it today with all of the cloud providers. So with AWS Batch, with Azure Batch, with Google Cloud Batch, and Kubernetes. So that provides that kind of full flexibility. Often this makes the things that we do with Tower a little bit difficult in the sense that we try and support all of these things. But ultimately, I think it has a really big benefit for the community to be able to access those features as well. Another couple of things that you can do here, and this is sort of in talking with the DevOps folks, you can start to enforce tags on compute resources. So you can say, no one can create a computer environment, for example, unless it has this tag. And that way you can basically define, you can basically stop people creating resources that they shouldn't be doing that, or at least organizing it in a way. You can typically structure from departments or into names, however you wish to do. And also this works straight out of the box with all of the existing cloud tools. So the fact that you're tagging the resources in the cloud environment means that you can visualize all of that as well. Okay, one last thing. That was kind of speaking about the accounting side of thing. So that's like once you've already spent the money. What can you do beforehand? Like what can we do to start to think about how we can do this before that? So kind of going beyond cost control. And this is something we've been thinking about for quite a long time. In fact, it was really one of the, even before we created Seqera 4 years ago, something we've really been working towards. If you can look at a Nextflow pipeline, and this is kind of in front of it for everyone. If you look at here, this is RNA-seq with, I believe, the full profile. You can look here and it says each of those processes is essentially using X amount of memory. The same thing for CPU there. So here you can see some of the CPU usage. And every time that you run the pipeline, maybe you have different data, maybe you have different sequencing depth, maybe you're running on a different species, you essentially have to go through and figure out how much they run. Or you don't, and you just pay a lot more. Because what's typically happening here is people are requesting the amount they know that has to work, essentially a very large amount of resources, and then end up paying for resources which are essentially not used. Okay, so our solution to that, which we're launching today, is resource optimization. Inside Tower, it's a one-click button. It allows you currently to take any pipeline which is run before, and you simply optimize it, selecting the button, and it will generate for you an optimized configuration. The way that it works is it looks at the task table inside of Tower, so it's got all of the information, CPU, memory, etc., and can then build from that model, which is then able to run. This is, I guess, definitely the version 1.0 that we have. We have big ideas on how this can be worked, though. So we've built a machine learning model on the back end, which can train on anything. So at the moment, we're just using CPU and memory for being able to train that, but you can imagine doing this on any piece of the task table. So you could train on container, you could train on input file size, and then you can also predict anything else. At the moment, we're just doing memory and CPU, but it also allows you to then, for example, maybe the exact instance types that you wanted, and kind of going from there. We think this is going to work really well. Here's some examples of it working. This is running Viral Recon 2.4.1. This is with testful nanopore. This pipeline took around, 378 wall hours, so CPU hours, and it cost around $9.90 to run. We could run the exact same pipeline with optimization, and now it's gone from nearly 400 to 100 CPU hours, and the cost has dropped to $1.54. So there is some significant changes and significant savings which can be raised from this. I should also point out that it's just really going to depend on the pipeline, like how optimized it is beforehand. But there is really a big opportunity here, even with just kind of a simple model that we're using at the moment as well. Okay, a little bit more on how it works. So why are you able to get such cost savings? Well, here is a look at an RNA-seq pipeline in this case. This is 3.8.1, sorry. This is basically the default that you get from running it. Normally, this is memory. If we apply the optimization there, you can see that instantly we're starting to make sure we're really just requesting the right amount of memory for each of those things. And this has two benefits, really, from requesting the right amount of memory and CPUs. The first one is that it means that we can get more tasks per VM. Some of the cloud providers, like AWS Batch, they place multiple tasks on those VMs. And because you're requesting essentially less amount of resources, essentially the right amount of resources, you end up with more of those tasks on there and therefore less VMs themselves. The other thing it means is that you actually get better instance types. So you can get the correct instance types there as opposed to requesting ones. And this is just a quick example kind of showing you how that would work with regards to that. I should also point out that this optimization is using the Nextflow directives. So it can work on any environment. If you have, for example, a Slurm cluster where you have to guess how much time, or you should say how much time the tasks take, it will also work in that situation as well. We are looking to open this up to basically make it so anyone can choose any parameter, train on any parameter, and build from there as well. Okay, so just a quick summary of those features. Obviously, Wave containers and Fusion. The Google Cloud Batch support and the resource labels is out, and the workflow optimization. Thinking about what's coming up next for us, obviously there's a sort of development team of Seqera is growing very rapidly, and we're really sort of excited about being able to deliver a lot more features coming out soon. We're thinking a lot about pipeline management and how that relates to runs, so the interaction between runs and pipelines. Doing a lot stuff on notifications and alerts, so be able to have a lot more information and make it a little bit more interactive. Obviously, the interactive environments themselves, and data management and data integrations. So I think there's definitely a lot to be done. It would be impossible to thank everyone. This is so many people's work that's gone into this. So I'm sure if I mention names, I'll miss someone out. But really, the whole Seqera team has done a fantastic job in building all of this out. The Nextflow and NF Core community provides fantastic feedback, support for building that. So thanks so much to them for that. We also have our customers now, and we're up to around 150 people are using Tower. Organizations are using Tower now, which provides us with a lot of feedback there. We also have, and really the kind of people, everyone here, I feel like when they have these events, sometimes there's just some themes which go through it. And definitely here I felt a lot on containers. We've definitely seen some kind of coming through on optimization, costs and stuff as well. So it's fantastic to have these events where we can essentially try out those ideas, bounce them off each other, and all learn together. And as I say, maybe that's a kind of a key part of open science. So thank you very much, and yeah, happy to take some questions.
Thank you, Evan. I've got a few questions for you from the audience. Let's start off with a couple of questions about the optimization feature that you mentioned there. One of the questions was, do optimizations account for input file sizes? For example, big versus small genome.
So currently it doesn't use the input file size as a training feature. This is coming very shortly. We actually just don't capture in Nextflow yet, so we're going to attach a small file inside of the task directory, which will just capture that, and then it will be just as easy to train on. So there's no reason why we can't do it. Let's say.
Matthias asks, can pipeline developers get feedback from the optimization to implement better process labels?
The last bit again, sorry?
Can pipeline developers, rather than users, get feedback from the optimization in order so that they better implement process labels within the pipeline by default?
Yeah, so with this approach, we don't typically have to use any labels anymore. So instead of saying, okay, this process is a large one, this is a medium one, with this, it will just generate exactly for that. So it's an automatically generated config that will say, okay, for multi-QC, XYZ, use six CPUs or whatever, and this exact amount. So you don't even have to use the label step anymore, let's say.
Aaron asks, how many runs do you need to train the optimization model?
Yeah, great question. So at the moment, the way that it works is that we're basing it on a successful run. So if you've got a successful run, you can optimize from that. The way that the system is it's a lot more generalizable than that. So you can, for example, do a collection of 5 runs, and you want to train on all of those 5 runs. So the idea is you'll select those 5 runs, you'll choose what you want to train on, what you're looking to predict, and it will generate on that. So it's very flexible. Currently, the one that's implemented in Tower Cloud is just single run, so one execution that's run successfully. That will just use that to train.
Moving on to a couple of other topics. James asks, are there any plans to update the community edition of Tower?
Yeah, this is something we've been talking about. It's been, I guess, kind of difficult to maintain multiple things of that. So it's something that we're looking to definitely do. Our timeline for that at the moment is probably more towards sort of middle of next year to be able to get that out. But with the increasing size of the development team, and we're going to change a little bit about the way we do those kind of releases, it should be possible to update that.
Okay, then I think last one from Remy says, will you also pick up and develop MegaQC or add similar functionality as MegaQC to Tower?
Yeah.
Maybe more for me.
Yeah, so the idea is really to build these foundational open science tools. As part of that, obviously, we'll be funding development team. We'll be building out as a project. We haven't done super great on branding in the sense that we have all these different small projects so far. So I'm not sure exactly how that will play out, but exactly in the sense that we will be developing it, building a team around it. Likely Phil will be involved, I hope.
Watch the space. Right, I think that's probably all the questions for now, so thank you very much.
Hey, thank you very much, Aaron.